Welcome to Lesson 9.9, Surface Areas of Prisms and Cylinders. So first off, let's look at just this idea of a surface area. So we know area of two-dimensional figures is the space that they occupy, the two-dimensional space they take up. Well, the surface area of three-dimensional figures we can think of as the sum of all the areas of the different faces or surfaces that are enclosing that three-dimensional solid. So if I think of a rectangular prism, the surface area would be the top area, so the area of that top face, area of the bottom, area of this front rectangle, area of the back rectangle, area of the right rectangle, and area of that left rectangle, all added together. So surface area, the sum of the areas of all the faces or surfaces that enclose a 3D solid. So let's look at an example. Example 1, brown paper lunch bag. We'll pretend that it's a perfect rectangular prism. Has dimensions of 5 inches by 4 inches by 10 inches. What is the surface area? So our first method, should be an ST there, but whatever. Our first method, find the area of each face and add them up. So we could find that area of the top, area of the bottom, and all the other 4 lateral faces and add them together. Works perfectly fine. A second method would be to use this formula. So we could think of the surface area being the area of the base plus that area of the overall lateral surface. And our overall lateral surface we could find if we kind of drew out the net. When we take a three-dimensional figure, draw it as a 2D, that's known as the net. So we could think of it like the net here. I just didn't draw the top here, but I kept the bottom for our base. So our base is a 5x4 rectangle. Our lateral surface is made up of the 4 vertical rectangles here, the left, the right, the front, the back. So they have a length combined of the 4 plus the 5 plus the 4 plus the 5 when we unfold it. And they would have the height of 10. So that would give us a large rectangle for our lateral surface that's 18 by 10. So if our surface area is the area of the base, our 5x4 plus our lateral surface, the 18 by 10, that'd be 20 plus 180, or 200 square inches. And if you use the first method, you would also arrive at the 200 square inches. So we have to think about, in that second method, if we're using our lateral surface, we have something known as lateral area. And the lateral area is that area of the lateral surface. So when we think about our formula for the lateral area, how did we find the lateral area? Well, if it's dealing with right cylindrical solids, the lateral surface area, or lateral area, of any right cylindrical surface is the product of its height and the distance around its perimeter. So our lateral area is represented as P, distance around its base, I should say, not its perimeter, but distance around its base, times the height. That is our simple formula for the lateral surface. So if we think about that, how did that apply to the net up here? Well, the distance around the base would be that perimeter of this base, 4 plus 5 plus 4 plus 5, and then multiplying it by the height of the prism, which would be 10, giving us that lateral area, the perimeter of the base, times the height of the figure. So then we move on to example 2. We have a figure here that is the half of a solid cylinder. We need to find the exact lateral area or lateral surface area, same thing. So first off, we need to find that perimeter of the base. So we need to find P, perimeter of the base. Well, we know this part is 6. We know that segment, which is the diameter if this was our whole cylinder. So that's segment 6. What about the distance of the semicircle arc? So how do we find that semicircle? Well, that would be half the circumference if that was a full cylinder. And circumference is pi times diameter. We know the diameter is 6. So that semicircle would be half of pi times 6. And then we have that segment length added in there of 6. So our perimeter of this base, the semicircle, could be represented by 3 pi, because a half times 6 is 3 pi plus 6. And we're going to leave it in terms of pi because they want the exact lateral area. So then using our previous formula, lateral area is that perimeter of the base, so 3 pi plus 6, multiplied by the height of our cylinder, which is 8. So 3 pi plus 6 times 8, distribute the 8, so 8 times 3 pi is 24 pi, plus 8 times 6, which is 48. So that would be our lateral area, 24 pi plus 48 for this half solid cylinder. Then we get the surface area formula for cylindrical solids. So any solid cylindrical object has the surface area, which is the sum of its lateral area and twice the area of a base, which is represented by this capital B. So our surface area formula for any cylindrical solid is the lateral area plus 2 times the base, or area of the base, I should say. So if I'd think of that, well, if I look at the cylinder down here, our base shape is a circle. So 2 of those plus this lateral area, the rolled up rectangle that makes the cylinder, would give us the whole surface area. So example 3 is doing exactly that. We're writing the expression for the surface area of a cylinder if its radius was r and its height was h. So if we didn't know the values, but we know the radius r, height of the cylinder is h, what would be the expression for the surface area? Well, the area of each base is represented by pi r squared, area of a circle formula. The circumference of each base, in terms of r, not diameter, well, circumference of any circle is 2 times pi times radius. So our lateral area would be 2 pi r h, because the circumference of the base, perimeter of the base, times the height gives us lateral area, 2 pi r h. So our surface area of any cylinder with a radius r and height h would be 2 pi r h plus 2, and then pi r squared in parentheses here. 2 times pi r squared, area of the base, plus 2 pi r h, the lateral area. So right there would be your surface area for any cylinder. If you simply know the radius and height, you would plug it into this formula right here. So, putting that to use. Example 4. Park entrances have concrete cylinders at the beginning of a pedestrian walkway to prevent cars from entering. Not present, that would be a mistake. If each cylinder is 1.3 meters high and the diameter of each base is 0.5 meters, how many concrete cylinders can be painted with a can of paint that covers 30 square meters? So in this case, let's begin with knowing that the bottom of the cylinder doesn't have to be painted, because obviously that's going to be attached to the ground or dug into the ground a little bit, but the bottom of the cylinder isn't painted. So we don't have to worry about two bases, we only have one base to paint. Then we know if the diameter of the cylinder was 0.5, the radius is 0.25. Just cut it in half. And then we know our surface area is the lateral area plus, in this case again, just one area of the base because we're not painting the bottom. So the surface area, our lateral area, is the perimeter of the base times the height. So the perimeter of our base would be 2 pi r times the height of the cylinder, which is h, plus the area of the base, pi r squared. So we're simply using this cylinder formula, but we're losing the 2 in front of the pi r squared because we're not painting both bases. So then we put in our info. Radius, 0.25, height, 1.3, multiplied by 2 pi, plus pi times the radius, 0.25, squared. So that would tell me the surface area is 0.65 pi plus 0.0625 pi, giving me the surface area of each cylinder to be painted as 0.7125 pi meters squared. So then if we wanted to find out how many cylinders would be painted with a can of paint that covers 30 square meters, we would take our 30 and divide it by the 0.7125 multiplied by pi and round it to our nearest whole number. Then moving on to example 5. Example 5 is dealing with a manufacturer that is making an anti-corrosive coating for millions of square nuts. So our square nut right here. In order to calculate the amount of coating to order, the manufacturer needs to know the surface area of a square nut. The square nut at the right has a side length of 1.5 inches. The cylinder hole is 1 inch in diameter. Thickness of the nut is 0.875 inches. Find the surface area of the square nut to the nearest thousandth of a square inch. So let's start to break down that surface of the nut. Well, the top and bottom, if we think about that, looking down on this, would be a square with the circle removed. So it'd be a 1.5 by 1.5 square. And that circle removed has a diameter of 1 or a radius of a half. Then we also know the lateral area of this box that makes up our square nut, so the lateral area of the box around the outside, would be made up of 4 rectangles, each that are 1.5 inches long and 0.875 inches in height. And then we have to deal with the lateral area of the cylinder. So the cylinder here. Well, that lateral area of a cylinder, when we unroll a cylinder, creates a rectangle. So if that had a diameter of 1, the length would be the circumference, which would be pi, because pi times diameter is circumference. So if our diameter was 1, that length would be pi, and the height would be 0.875. So then the surface area of that nut that's going to be coated. We have to deal with the top and the bottom, plus the lateral area of the box, plus that lateral area of the cylinder. So what's getting coated would be these four sides, the top, the bottom, and the lateral area of the cylinder right here. Because that cylinder was cut out, that inner cylinder needs to be coated. So let's plug in our info. The top and bottom, well, we have two squares there that have an area of 1.5 times 1.5 minus the circle that was removed. And the circle that was removed would be minus 0.25 pi. Then we have the area of the box, which would be 4 multiplied by the area of these rectangles, 1.5 times 0.875, which is 1.3125. And then we have the lateral area of the cylinder, this rectangle, 0.875 times pi. So if I then plug in all this information into a calculator and round it to the nearest square inch, the surface area of each nut would be 10.928 square inches.